Well, we will talk therefore about the cuffs and endotracheal tubes, and do have a problem with them. But before starting off, and you see already here on the right the different available or even new tubes that might be coming out, have to let alone that I've been giving lectures for many companies, but in this talk I will talk also about a product that I've been developing by myself. It is not on the market yet, and therefore I have to let you know that I have a conflict of interest on this subject. Nevertheless, I will try to be objective and show the real data as they're coming through. Do we have a problem with endotracheal tubes and with cuffs? Well, just shortly, we tend to use a lot of laryngeal masks that do not fit at all. Nevertheless, they are easier, safer, quicker, and less traumatic. So endotracheal tubes are real traumatic. The cuffs are also traumatic, as Luc was already telling us. So we frequently stay away of the endotracheal tubes if possible. In small children, cuffless endotracheal tubes are very frequently still used because of the cuffs taking a lot of space. But at this moment, you really have a lot of leak and a possibility of fluid leaks also. You know that in the past 10, 15 years, new tubes have become available, most of the time used on the intensive care together with subglottic suction, like the taper guards and the microcuffs, just to name a few of them. Nevertheless, they still leak fluids and they still leak air, creating still some problem. Endotracheal tubes, and I will go on a further list, difficult intubation, but with the video laryngoscope, such aspects are less a real problem. Vocal cord trauma, tracheal wall trauma, just by compression. We are compressing against the cartilage, and certainly with large balloons, we are compressing over a larger area. And now we call the silent aspiration. Well, there is fluids that's going down in the trachea, and if you do bronchoscopy, you will see it like that. And then air leaks. Now, air leakage, you can find that on your ventilator, and certainly if you look here, you will see that the ventilator is not, well, I have to come back here, is not coming up to the full position. Means that your fresh gas flow is not enough, even at half liter or 1 liter. Other ventilators, like the Dreyer, is shown here in the red zone, meaning your fresh gas flow is not enough. Now, most ventilators will measure the inspired and the expired tidal volume, but for a long time have been asking, just give the figure of the leakage, even in liters per minute. That would be very easily. No company would like to do that, and the reason is that the inspiratory flow sensor and the expiratory flow sensor are different. And we do not calibrate the sensor each day. And that means that on your ventilator, you might see a difference between inspiratory and expiratory, sometimes of more than 1 liter, although there is 0 leak. So never rely on that difference due to this calibration that is missing. So if you want to know it, you need to have a separate flow meter. A few ventilators have the same flow meter for inspiration and expiration and doesn't have that problem. Now, I will not go into the problems of subluxation on the vocal cords. That's why the video laryngoscope makes a real look here. You're pushing in, you get a subluxation, and happily it came back. Now, if you do blind intubation and you are not aware it came back, you will have a patient with persistent hoarseness, that being a real disaster. It can happen also during extubation when the cuff is not deflated. So be careful on that. But the leakage, well, I was already working on that for a long time ago when I was investigating the impact when the taper guards came on the market. I figured out if you put gel on the cuff, it helps also to fill up, because otherwise the high volume, low pressures, there always leaks immediately. With gel, you can postpone that a little bit. Nevertheless, it still will be some leak available, what you will see there on methylene blue. The microcuff came also on the market. The microcuff is a very, very ultra thin membrane, and it will not give any plica, so that means that there will not be plica as what you will see here in this one. A lot of plica were always running through. There are also plica with the taper guard, but there's somewhere an area where the diameter of the cuff identical to the diameter of the trachea. Now with the microcuff, there was a lot of things solved. and it seems to be great, certainly when the PEEP levels are high enough. But once you come to 0 PEEP levels, and we've seen that PEEP is not always that good, but I would love to have water some PEEP to prevent some leakage of fluids, but then you will get leakage of air. You will see that even these taper guards, microcuffs, will start leaking. There's another aspect also, that if you do suction, and you shouldn't do that at the end of the procedure, but on the intensive care, due to a lot of mucus, we have to suction this mucus away. If you go in with a suction catheter, and normally you should be starting, showing, but, no, he didn't start anyway, but look, on the moment you go in with a catheter, you get real negative pressures inside, and all cuffs, also the microcuff, will start leaking immediately. And this has to do with the real negative pressures here. One solution you can do, and that was something introduced in the past, was using the Busignac air amplifier, by which you can give a continuously PEEP of 15 while you suction inside. And this is an open system. You can do also put your ventilator on pressure controlled. It's the only situation where I love pressure controlled, otherwise I love volume controlled for other reasons. And then you will maintain a positive pressure here inside while you suction. But if you suction, you should be aware, you should use a catheter that is maximum half the size, because otherwise you get these real negative pressures inside. And you should use maximum minus 100 centimeters of water. I hardly see everyone doing maximum power, going in, staying there for a few, 5-10 seconds. This is always a disaster. You get atelectasis, you get aspiration of fluid from the oral cavity inside the trachea before you're taking it out. It may be clean, but it's infected. And as you can see here, the acceptable sizes of suction catheters is extremely low. So never use this 14 French, 16 French orange, the green one from 8.5, the black one for 7. These are small catheters. So if you use these thicker ones, you get real negative pressures inside with leakage dramatically. So things we have to take into account. A new tube was also recently developed, that's the Pneumo X, and that's the one that has a special controller, and we go to very high pressures in the cuff, but they measured the tracheal wall, and they said for a pressure of 80, you only have a pressure of 30, 35 against the wall. But they do not measure that continuously, so you're not fully aware. But by these higher pressures and a balloon, again without any pliqué, you might have no leak or zero leak. But we are not absolutely sure that these wall pressures stay that low, and that's theoretically. So I'm a little bit afraid to start using that. You need also special tools to get these values there. That's why I start thinking we still have a real problem. And on the day when I opened the water pump of a bicycle pump, I came out, look here, what's this valve doing? This is actually a cup, and you can move the cup down without any pressure, and when you bring it up, it closes. And the higher the pressure you generate, the better it closes off. Now, we should make a cuff in the same aspect, but it's not moving in the trachea, it's still. So we should have a cup that is a little bit like such a water pump. And the higher the pressures here in the lungs, the more it presses the cuff against the tracheal wall. And then you don't need high pressures in the cuff. You can even have pressures in the cuff below the 25 centimeters of water. But we still have a problem when you aspirate, that fluid might come down the other direction. So for that, I designed also a cup on the other side. So if you do a suction with negative pressure of minus 100, this cup will immediately close off against the wall, and there will be still atelectasis. So to be careful, don't still use small tubes, but at least you will not have a fluid coming in the trachea. So we have a cup for preventing the aspiration during suctioning, and a cuff for preventing the air leaking actually out. I'm not sure that the video has come through because the other video was not running, but let's see. Yeah, this one is running. See, as an example, we have the new tube here, the Cloud Guard. We have the microcuff, the best available on the market, that is most of you not using. And here the traditional high-low volume or the taper guard. We will just be breathing, ventilating with a balloon. We measure here continuously, automatically keep the pressure in the cuffs at 25 as recommended. This with an automatic control. We should always use, most of them inflated by hand. And here the pressure recording in the airways. As you can see, dramatic leak in the classical tube, still leak in the micro cuffs, and zero leak in the new designed Cloud Guard tube. Now, can this explain one of the problems we have with absorption? For that, I look back to data when I was still working in Broods, together with Alain Calmar, who is also here, and my son. He did a study on measuring how much SEVO can be captured by the contrafuran. And what we figured out there was that in low flow, at maintenance, we could capture, well, we consumed 11.2 milliliters of sevoflurane, and we captured only 1.6. It means we worked at very low fresh gas flows. That was great. That was what we could capture. It was still sitting in the patient. During washout, and we went up to below 0.4 till the patient was awakening, we captured another 3.8 milliliters of sevoflurane. We measured that in weight and brought that back in milliliters because it's heavier than water. And the total capture is only 45% during maintenance and washout. It means that 55% is lost or is still remaining in the body of the patient and washout during the recovery room. Maybe the reason why we need better ventilation in the recovery room instead of in the ER. But if you calculate for, these were obese patients, and on an average of 98 kilograms, at an end of the duration 0.2%, then it means only 1.2 milliliters of sevoflurane remaining in the body of these patients. So where is the other 5 milliliters? Well, the leakage of our endotracheal tubes, and we were using in this patient group taper guard tubes that's well better than the high volume low pressure cuffs we traditionally use, we still had some leaks. And the ventilator might tell this is 500 milliliters, but that indeed is not real exactly. But for a mean duration of 1 hour and a half, this is exactly to a leakage of 500 milliliters per minute of gas leaks at an assumed concentration of 2%, 3.3 milliliters per hour. This is a huge amount that is leaking. So it's very bad for the environment. And even if you start using this absorption system, be aware that this leak is indeed a problem and that we should solve first this leak before really thinking about capturing systems. So do we have a problem with endotracheal tubes and cuffs? Well, laryngeal masks are useful, frequently used because of the troubles of the endotracheal tubes. But many can be managed like with video laryngoscope, with cuff management. We should measure the pressure more exactly. And actually, we need to look to these more advanced endotracheal tubes, compare them with our classical ones and the laryngeal mask. And with the very low pressure cuffs, we will keep the perfusion also a lot better. These cuffs are also very small, not a huge area. It means the perfusion is only on a very small area limited, while the large volume cuffs, they really are compressing over several centimeters. I would say treat every patient if it's an opera singer who comes with you. And then we would use a laryngeal mask, or you would use even an endotracheal tube of only 6 instead of 8. Recruit always after suctioning the endotracheal tube. It's still important because the atelectasis is not really solved, and think about the size of these suction catheters. If you want to think about SEVO capturing, then you really need zero air leak, otherwise it doesn't make any sense. Thank you.